Geometry 8.1 Part 1. The Pythagorean Theorem and its converse. In this lesson, we're going to learn how to use the Pythagorean Theorem. Okay, well, what problems can the Pythagorean Theorem help solve? Well, if a triangle is a right triangle, then the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So if triangle ABC is a right triangle, where side A and B are the legs of the right angle, and C is the hypotenuse, we can say A squared plus B squared equals C squared. Okay, a Pythagorean triple is a set of non-zero whole numbers A, B, and C that make the equation A squared plus B squared equals C squared. Below are some common triples: 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. If you multiply each number in the Pythagorean triple by the same whole number, and the three numbers that result also form a Pythagorean triple. Notice the Pythagorean triple 6, 8, and 10, 5, 12, and 15 each result from multiplying the numbers in the 3, 4, 5 triple. So how do we find the length of the hypotenuse? So let's say we're given two sides. We're given AC equals 20 and BC equals 21. Well, those are the sides. So we can use the Pythagorean theorem. Leg 1 squared plus leg 2 squared equals hypotenuse squared. So I'm going to get 21 squared plus 20 squared equals C squared. So when I simplify that, 21 squared is 441. 20 squared is 400. So 441 plus 400 is 841. So C squared equals 841. So C equals the square root of that. So C is going to be 29. So the length of the hypotenuse is 29. Okay, look that over. See if that makes sense. And if it does, let's move on. Alright. The legs of a right triangle have lengths of 10 and 24. What's the hypotenuse? So let's just sketch a right triangle. Okay, we have a leg of 10 and a leg of 24. So we know A squared plus B squared equals C squared. So 10 squared plus 24 squared equals C squared. Well, 10 squared equals 100. 24 squared, okay, again, if we're not sure, let's just use our handy dandy calculator. 24 times 24 equals 576. So plus 576 equals C squared. So 676 equals C squared. So let's find the square root of 676. It's 26. So 26 equals C. Okay. Do the side lengths form a triple? Yes, they do. So I have 10, 24, and 26. I can factor it all by 2. I can get a 5, 12, 13 ratio. Okay. Find the length of a leg. So I'm given the hypotenuse and one of the legs. So I have 20 and 8 in the unknown side. So A squared plus B squared equals C squared. Okay, we'll make our A value 8. So 8 squared plus X squared equals 20 squared. So I get 64, because that's 8 squared, plus X squared equals 400. Subtract 64 to each side. So I get X squared equals 336. Take the square root of 336. Alright, this is leaving simple radical form. So we're able to make that 4 is root 21. Okay. So the hypotenuse of a right triangle has a length of 12. One leg has 6. What is the other length? So 6 squared plus X squared equals 12 squared. So 36 plus X squared equals 144. Subtract 36 to each side. Give you a second to catch up and write this down. X squared equals 108. So X equals the square root of 108. Which 108 prime factors the 36 times 3. Well, what's the square root of 36 times square root of 3? So x is 6 root 3. Okay. Finding distance. A dog agility course often contains a seesaw obstacle. To the nearest inch, how far above the ground are the dog pars when the seesaw is parallel to the ground? Okay, use the Pythagorean Theorem. A squared plus b squared equals c squared. Okay, we have a side of 26 and we have a hypotenuse of 36. So we're just going to use the Pythagorean Theorem. We're going to substitute 26 squared plus b squared equals 36 squared. Simplify, so we get 676 plus b squared equals 1296. Subtract 676 from each side. I get b squared equals 620. Square root each side. B equals 24.899, or we can say 25 inches above the ground. Okay, last example. The size of a computer monitor is the length of its diagonal. You want to buy a 19-inch monitor that has a height of 11. Round to the nearest tenth, what is the width? So I can say a squared plus b squared equals c squared. So that's 11 squared plus b squared equals 19 squared. Okay, well 11 squared is 121 plus b squared equals, okay, I don't remember what 19 squared is off the top of my head, 361. So I'm going to subtract 121 from each side. So I'm going to get b squared equals 240. So b is going to be the square root of 240. All right. Square root of 240. 15.5. b equals 15.5. So it's to the nearest tenth, so that's good. Inches. All right, easy enough? Okay, on to the next one. Okay, what problems can the Pythagorean help solve anytime there's a right triangle and we know two of the sides? Okay, let's look at some examples. Okay, simplify in simplest radical form. Let's look at number 1. So I got a squared plus b squared equals c squared. So I'm going to get 35 squared plus 12 squared equals c squared. So it's 35 times 35 is 1225. And 12 squared is 144. So 1225 plus 144 is going to be 1369 equals c squared. So we're going to square root each side. So c is going to equal the square root of 1369. So when we do the square root of 1369, we get c equals 37. Pythagorean triple. All right, number 2. I've got a squared plus b squared equals c squared. So I have 7 squared plus 9 squared equals c squared. So it's going to be 49 plus 81 equals c squared. So c squared is going to equal 130. So c is going to be the square root of 130. Alright, well 130 factors 2 times 65. 65 factors down to 5 times 13. Okay, and 5 and 13 and 2. So c is the square root of 130. We cannot reduce it any more than that. Okay, well that's our lesson for today about the Pythagorean Theorem.